Lesson number 7. Motion, Force and Work. Question number 1. Fill in the blanks with proper words from the brackets. First, if a body transfers a distance in a direct proportion to the time, the speed of the body is constant. Second, if a body is moving with a constant velocity, its acceleration is 0. Third, speed is a scalar quantity. Fourth, velocity is a distance traversed by a body in a particular direction in a unit time. Fifth, when an object comes back to the point of origin, its displacement is 0. Question number 2. State whether the following statements are true or false. First, when a body performs uniform circular motion, its acceleration remains constant. Answer false. Second, displacement of a body and distance covered by the body in a given time interval have always the same magnitude. Answer true. Third, the direction of acceleration can be opposite to that of velocity. Answer true. Fourth, acceleration can be perpendicular to velocity. Answer true. Fifth, deceleration has magnitude and direction. Answer true. Sixth, the average velocity of the body can be 0. Answer true. Question number 3. Find the odd one out. Acceleration, force, velocity, speed. Answer force. Match the following. Work, Joule, urge. Force, Newton, Dan. Displacement, meter, centimeter. Question number 5. Answer the following questions in one sentence each. First, state the quantities that must be specified to describe force. Answer, mass and acceleration. Second, what happens when a force is applied in the direction of motion of a body? Answer, if the force is applied in the direction of a motion of a body, it increases its speed. Third, what happens when a force is applied in the direction opposite to that of a body? Answer, if the force is applied in the direction opposite to that of the motion, it decreases its speed. Question number 6. Define the following terms and write the SI and CGS units for the same. First, distance. The length of the route actually traversed by a moving body irrespective of the direction is called a distance. SI unit is meter, m. CGS unit is centimeter, cm. Second, velocity. Velocity is the distance traversed by a body in a specific direction in a unit time. SI unit is meter per second. CGS unit is centimeter per second. Third, speed. Speed is the distance traveled by a body in a unit time is called speed. SI unit is meter per second. CGS unit is centimeter per second. Fourth, acceleration. It is the change in velocity per second. Acceleration is equal to change in velocity upon time taken for change. SI unit is meter per second square. CGS unit is centimeter per second square. Question number 7. First, a bird sitting on a wire flies, circles around and comes back to its perch. Explain the total distance it travels during flight and its eventual displacement. Answer, the total distance the bird has traversed is the length of the distance covered by circling, but the displacement is 0 and its initial and final position are same. Second, what is the direction of velocity of a particle performing uniform circular motion? Answer, in uniform circular motion, the direction of a velocity is along the tangent drawn to the position of a particle on the circumference of the circle, and the velocity also remains constant. Third, Explain the following concepts in your own words with everyday examples: force, work, displacement, velocity, acceleration, distance. Force. The interaction that brings about the acceleration is called force. Example: an ox is pulling a cart. Work. When an object is displaced by applying a force on it, work is said to be done. Example: a boy pulling cart. Displacement. The minimum distance traversed by a body in a one direction from original point to reach the final point. Example: a rolling of a ball. Velocity. Velocity is the distance traversed by a body in a specific direction in a unit time. Acceleration, change in velocity per second. Fourth, a ball is rolling from A to D on a flat and a smooth surface. Its speed is 2 cm per second. On reaching B, it was pushed continuously up to C. On reaching D from C, its speed has become 4 cm per second. It took 2 seconds from it to go from B to C. What is the acceleration of the ball as it goes down from B to C? Answer: as its initial and final position are one and same, initial velocity is 2 meter per second, final velocity 4 cm per second. Time taken for the change in velocity from B to D is equal to 4 cm per second minus 2 cm per second is equals to 2 cm per second. Acceleration is equals to change in velocity upon time taken for change. So is equals to 2 cm per second upon 2 second is equal to 1 cm per second square. Question number 8. Distinguish between. First, distance and displacement. Answer: distance and displacement. First, the length of the route actually traversed by a moving body irrespective of the direction is called distance. Second, it is a scalar quantity. First, the minimum distance traversed by a moving body in one direction from the original point to the final point is called displacement. And second point, it is a vector quantity. Second, speed and velocity. Speed. First, speed is the distance traversed per unit time. Velocity. Velocity is the displacement traversed per unit time. Question number 9. Give scientific reasons. First, distance and displacements are different concepts. Answer: distance is the length of the route actually traversed by a moving body irrespective of the direction. It is a scalar quantity. Displacement is the minimum distance traversed in a particular direction along a straight line. It is a vector quantity. Therefore, distance and displacements are different concepts. Second, when a body falls freely to the ground, its motion has a uniform acceleration. Answer: when an object falls freely to the ground, it is under the effect of a constant force known as the force of gravity. Hence, acceleration remains uniform. Second, acceleration is a vector quantity. Is force a vector quantity too? Answer: yes. Acceleration and force both are vector quantities because both are expressed completely only when magnitude and direction are given, and the quantity which needs direction and magnitude both is called a vector quantity.